In section R3, we're going to be finding the domain and range of lots of functions. And if you look at the objectives, you can see that we're also going to practice interval notation and also set notation, and also putting a big emphasis on domain. Domain is something that can be skipped over by lower level classes, but is very important for us to understand domain and range when we're looking at functions, especially as we look at their applications in business calculus. So you want to make sure that you understand how to write it and also how to use different notation. Interval notation is similar to graphing on a line graph. You want to make sure the numbers go from least to greatest, from left to right, and then the symbols at the end tend to resemble each other. Let's see what they look like. On this number line, we have an interval going from -3 to +4, and you can see because it's shaded in that the interval in between them is what we're talking about. We are not including -3 because it's an open circle, but we are including +4 because it's a closed circle. Now this is how the notation used to be, but now we tend to use parentheses for the open circles and brackets for the closed circles. If I were to write this interval in interval notation, I would use a parentheses for the -3, and then I would put the 4 on the other end and use the bracket notation. This means that we're not including -3 in our answer, that we are including +4 in our answer because of the way that we use the parentheses and the brackets. Some of the notation when you look at the line graphs has changed, so instead of open circles and closed circles, you might see brackets or parentheses on them. This makes it fairly easy to translate the line graph into an interval notation. Here we have the line starting at 1. We are including the 1 in our answer, so we're going to put 1 on this side with the same symbol, the bracket, and then on this side it's going on forever, so we're just going to go to infinity, and infinity always has a parentheses. So you want to make sure to do that. This next number line has an arrow pointing to the left, but whenever we write this in interval notation, we always want to go with the least number first and then the highest number second. So the least number here, well, this is going to -infinity on this side, and -infinity, like infinity, always has a parentheses. Now the highest number here on our number line is a 2. So we're going to use that as our border, and it has a parentheses there, which is similar to the open circle, meaning that 2 is not part of our solution set. And so notice that on the green graph and the green interval notation, we put 2 on the right-hand side. But when we did the pink one, we put the 1 on the left-hand side because that was the least number there. And it's really important that you put the number on the correct side when you're using interval notation. Starting with example 1, I want you to notice that A and B are written in algebraic set notation. Algebraic because it has the inequality symbols, and set notation because it has the braces around the algebraic statement. And this means that all values of x that I'm looking at are the values of x between the 3 and the 7. Now, you have to be very careful with your parentheses and your brackets and your braces. Right now you're looking at braces, and now we want to write this in set notation. I want to write my x's to be in between the 3 and the 7. So I'm going to put the 3 and the 7 as the beginning and ending of my interval. It's greater than 3, so I'm going to use parentheses. It's less than 7, so I'm going to use parentheses. And there we have it. Now the next one we have, it says the set notation is the set of all numbers that are less than or equal to -3. So I want numbers that are less than -3. And so I want numbers all the way down to -infinity, all the way to -3. -infinity will always have a parentheses on it, always. But the -3 is equal to the x as well. So we're going to put bracket here because of the equal to symbol. Continuing on with example 1, we have this interval that's between 1 and 5. And so I'm going to put 1 on the left-hand side. I'm going to put 5 on the right-hand side. It's a closed circle here on the 1, so that means bracket. It's an open circle here on the 5, so that means parentheses. And then let's look at the next one. It is an interval going from -infinity to 5. 5 is the highest number, so we're going to put that 5 on the right side of this notation, and then on the left-hand side, the lowest number here is -infinity. So we're going to keep it on that side. Once again, always parentheses on infinity or -infinity, and then parentheses here on the 5 because it's an open circle. It's not included in my solutions. Because it's so easy to translate something from line graphs to interval notation, sometimes when I have something in set notation, I imagine it first if I graphed it. So let's go ahead and graph it. And I usually only find it necessary to put the numbers in that pertain to my question. I have it open at -4, so open at -4, open at -2, and my x's are in between those two values, so I'm going to highlight that. And then my x's are also greater than and equal to, so I'm going to put closed circle because it's equal to the +1. And so notice that when you have something like this, I actually have two intervals. So I want to write both intervals. I'm going to write -4 on this side and -2 on that side of that interval. And I'm using parentheses because those were both open. And then over here I'm going to use bracket because it's closed, because it includes the 1. And I'm going to go all the way to infinity. That's not on my number line, but you can put it if you want. Now, I have two intervals here. I need to join them with a union symbol. And I always use a union symbol if I have two different ones, two different intervals joined by the word or. Let's go ahead and do the next one. Once again, I have two different symbols. I have two different statements. X is less than or equal to 0 and x is greater than -3. Let's draw that on the number line. Now, one thing to notice is that this is joined by the word and, so we have to be very careful with that. Let's go ahead and do our intervals. X is less than or equal to 0. I'm going to put it above the number line. And I'm going to put it equal to 0 and going that direction. And then x is greater than -3. It's going to be open circle on -3, and then greater than going this direction. But because it says the word and, I'm looking where both lines overlap and both lines exist. They overlap here. At the -3, it's an open circle. At the 0, it's a closed circle. And they overlap in this part because we need our solution to satisfy both statements. It says and. We need our final interval to be both less than or equal to 0 and greater than -3. So open parentheses, closed bracket. And so that's our interval, always from least to greatest. For this next question, it asks us to answer some questions based on the graph that we're given of g of x. The first three parts are straightforward based on our given x values. So it says g of -1, and -1 here is the -1 references the x value. So we're looking at the graph when x is equal to -1, and the answer would be 4. The same thing with g of 1. We look at 1 on the x values, and we see that the y value is 2. The third question asks us to find the domain of g, and that is all the x values that are graphed. So it looks like we start at -2, and we end at +1, and all the x values in here are the values that are graphed. And so it's a continuous portion, and so we would talk about that as an interval. We do have the -2 as part of that interval. We also have the +1 as part of that interval, and we're talking about all of the x values in between. So that's going to be from -2 to +1. Our domain includes the -2 and the +1. The next question asks us to find the number or numbers in the domain that is paired with the one from the range. That is, find all the x values for which g of x is equal to -1. The -1 is our y value, so we're looking at the -1 here, and it corresponds to this point. And so the x value which gives us this is -2. X is equal to -2. This is different from the first two questions we were asked. When we were asked, find g of -1, that -1 was our x value, then we found the y value of 4. But when g of x is equal to -1, then that x is equal to -2. Now that I'm asked to find the range of g, I want to find all the possible y values. So the highest y value I see is the 4, and the lowest y value I see is the -1, and we're talking about all the y values in between this. So we want the interval from -1 all the way up to +4, including the -1 all the way up to the +4. So we'd say from -1 to +4. Notice that when I did the domain, I drew on the x-axis to figure out all the possible x values. Now that I'm doing range, I'm drawing on the y-axis to find all the possible y values. For the next few functions that we're doing in examples 3 through 6, you do want to make sure that you understand what types of functions we're looking at and what the rule is for those functions, so that you can apply it to other questions. The first question is find the domain of an absolute value function. And for absolute values, anything can go inside that absolute value symbol. So the domain is going to be all real numbers. Writing that in interval notation, we would say from -infinity to +infinity, including the endpoints. The equation could look more complicated, but as long as it's just an absolute value question, no matter what's inside of it, the domain is still going to be all real numbers. It doesn't matter if there's stuff inside and outside the absolute value, as long as it's all polynomials, and the domain is always going to be all real numbers. So that's the rule for absolute value equations. For question number 4, we want to identify that this is a rational function because it has a fraction and it has a variable in the denominator of the fraction. So that tells us that this is a rational function. The rule for rational functions is that the denominator cannot be 0. In order to solve for the domain, we want to take that denominator, 3x plus 6, and say that that cannot be equal to 0. And then as we subtract 6 from both sides, and then divide both sides by 3, then that gives us what our domain is. Our domain is all real numbers except for -2. On a number line, that would be not the -2, but every other number. Personally, I'm happy with the algebraic answer like this, where x is not equal to -2. But if we wanted to write it in interval notation, you have to recognize that there are actually two intervals here. The interval from -infinity to -2, not including the -2, and also the interval from -2 to +infinity. So you can see you have to get intervals on both sides of that -2, because that's the only number that we're not using, but we're using every other number. It's much more complicated to write it in interval notation than it is in regular algebraic notation. With our next example, f of x, where we have a numerator with a variable and a denominator with a variable, the only thing that matters for the domain is that the denominator cannot be 0. So we can ignore that numerator, and we can just say for x minus 3 is not equal to 0. And once again, so you would have x is not equal to 3/4, and writing that in interval notation, we would get -infinity to +3/4, union +3/4 to +infinity. And so that's written in interval notation and also in algebraic notation. This next function is a radical function, not to be confused with the rational function that we just finished, but radical because it has a radical sign, and it has a special domain. The radicand, the part inside the radical, cannot be negative. It can be positive and it can be 0. And we write positive as greater than 0, and write 0 as equal to 0. So let's do the first example. 8 minus 5x is my radicand, and that cannot be negative. In other words, it has to be greater than 0 or equal to 0. And it's important that when you write this, you use your inequality symbols and not just an equal sign. You want to use greater than or equal to 0. As we solve this, I'm going to subtract 8 from both sides. Then I'm going to divide by a negative 5. And you have to remember that when you divide by a negative, when you have inequality symbols, the inequality turns around. And that's why it's really important to use our inequality symbols right at the beginning when we set this up, and so that when we're solving it, if we need to do anything with it and if it needs to turn to the other direction, then we can have our answer facing the correct way. X is less than or equal to 8/5 would be written as an interval going from negative infinity to positive 8/5. We would not include the negative infinity, but we would include the 8/5 because of the equal to symbol. So here is our algebraic solution, and here is our interval notation. And just to throw an extra example at you, you want it to say 2x plus 10 is our radicand. We want to make sure it's greater than or equal to 0. So you want to move that over and say 2x is greater than or equal to negative 10. And this time, I'll divide by positive 2. So I'm going to get x is greater than or equal to negative 5. Notice that because I divided by a positive, it didn't change directions. But I want the values of x that are greater than negative 5. So my negative 5 is going to be on this side of my interval, and then I'm going to go all the way to positive infinity. So you can see how we need to use that inequality symbol because that tells us on which side of my interval notation my number is going to be. For a question like number 6, where you might have two radicals, then you have to make sure that you apply the rule to each radical. Likewise, if I had two fractions and I had a rational equation, I have to make sure I apply it to every single denominator. Anytime you have a special rule, and if you see that in your question, you want to apply that rule to what you have. So here I see two radicands. I'm going to set both radicands up in inequalities. So the first one should say x plus 1 is greater than or equal to 0, and then 5 minus x is greater than or equal to 0. And I want to make sure that whatever answer I get is valid with both inequalities. So the first one is very easy to solve. It's x is greater than or equal to negative 1. The next one is negative x is greater than or equal to negative 5. So we're going to divide by negative 1 and turn that symbol around. And so I have this. Let's graph it to see what I have. And here I have a very simplified line graph. I'm going to have numbers that are greater than or equal to negative 1. That's coming from this portion. And I have numbers that are less than or equal to positive 5. That's from this portion. And I want to make sure that any number that I use won't break either of these radicals. So it's an AND type of situation. I only want the numbers in between the negative 1 and the positive 5, because I have to make sure both intervals are respected. So I'm going to say the numbers from negative 1 to positive 5 are my solution. And this is once again in interval notation. We're moving on to our last question, which is a word problem. And it says, let C of t be the cost to rent a minivan given the information above. And that's also written in your notes, so I'm not going to read it. You can read that. And we're going to use C of t to determine what this is, what our cost is. And it says, what's C of 1.5 in hours? So it says here, the hourly rate to rent a minivan in Florida is $12.30 per hour for any part of an hour. And for any rental period of more than 2 hours, the daily rate of $36.90 applies. Since this is 1.5 hours, that's basically the same as 2 hours. And we're going to say then that's 2 times $12.30. So that's going to be $24.60 for an hour and a half. All right, that's going to be the cost to rent the van for an hour and a half. It asks us now to find C of 20. What's the cost to rent the van for 20 hours? Well, looking at this question, any rental period of more than 2 hours pays a daily rate of $36.90. So it's going to pay the daily rate of $36.90 for 20-hour rental. The third question asks us, what is the cost if I want to rent it for 48.5 hours? Let's break that down. That's going to be the cost of 2 days plus 1/2 hour, which is a portion of 1 hour. And so we want to break it down conceptually, and then we're going to say, well, that's 2 days worth plus 1 hour Let's see what that cost is. $73.80 plus $12.30. So that's going to be $86.10. And that's $86.10. That's to rent it for 48.5 hours, which is 2 days and a portion of 1 extra hour. To find C of 80, that's 80 hours. How many days can we do that? We want to divide 80 by 24, and we would get 3 full days and 8 extra more hours. And so that's really just going to be the same as the cost of 4 days, because that 8 hours of that 4th day is more than the 2 hours that they would charge for at an hourly rate. So they would just charge for 4 days. So 4 times the hourly rate, 4 times the daily rate. Using my calculator, I got $147.60. Alright, so a question like this, which maybe has some weird rule, you don't necessarily have to come up with an equation for it, but you do need to understand what each portion is, so that way you can sort of figure out a formula. And notice that I just wrote sort of my concepts like, oh, I think that's 2 days plus an extra hour, or that's 3 days plus an extra 8 hours, which ends up as 4 days. And once I wrote it like that, then it helped me come up with an equation, which I then solved to come up with a total cost. So you don't have to come up with an equation that describes it, but you do have to come up with the concept and understand what the question says. And that's it for the section. Thank you and have a good day.